Tonight's lecture is going to be on a topic which has quite a lot of relevance to what's happening here and indeed what's happening locally. Henry Acevedo had spent much of his life, 20 years or so, in the business of software development, automation and robotics. And 7 years ago, he founded a local company called Fox Robotics. My research suggests that they've done quite a lot of work in automation and then moved into the area of farming. So he's going to tell you about what they do and the impact it's likely to have.
Engineering is the melting pot of innovation, where science, technology and design come together. Whether you think about the invention of the wheel or the first use of fire to change the property of materials, engineering has always been at the heart of mankind's development. From energy, transport, design and production, built environment, to IT and communications. Formed in 1871 and incorporated by Royal Charter in 1921, the IET is a world-leading professional organisation, sharing and advancing knowledge to promote science, engineering and technology across the world.
Good evening, everyone. My name is Henry Acevedo. I'm the CTO and the founder of Fox Robotics. And today we were going to talk a little bit about robotics in farming, and especially a little bit more about what we do as a Fox Robotics. So the title, this presentation is the robotic farming and the future of the future generation of field workers. Sorry, my accent is Spanish. So I'm Colombian national. So if I struggle with English, my apologies a little bit, but I'll do my best. So for today, the agenda is going to be very high level. I'm not going to drill into the details of the robotics itself, but I can answer some questions about it. We're going to talk a little bit more about the, bit about the history, the agriculture. Then we talk about the current state of agriculture. Then we talk into the introduction of automation, then some key technologies that is used in agriculture, in robotics, and of course benefits, some case studies, and of course we go for the Q&A. So history about agriculture. I'm not going to spend too much on this slide, but pretty much the first, let's say the first agricultural revolution started when people start to, hunter-gatherers start to understand how to cultivate plants, right? So we talk about 9,000 years ago. So it's the domestication of plants. That's the first big milestone that makes societies and makes basically societies to become bigger and bigger. So the second agricultural revolution started around 1600 to 1900. The major things were basically some introduction on some better tooling, some land enclosure to ensure that you can create, or we have space where it's dedicated exclusively for agriculture, and of course crop rotation. This is one of the second revolution. The third revolution actually started quite not long ago, 1900s. It's pretty much machinery, right? And especially back then, of course, people were using wamo as a source for hydrogen within plants and other chemicals. So that once BAF, the German company, identified how to create it chemically, wamo basically become obsolete, and agriculture started to become more industrial. And of course, starting to look into 1940s, 1940s, is the tractor. That's the biggest, I will say, tool that push a lot of our industrialization in terms of the agricultural revolution. Now we're talking about the fourth generation, the fourth agricultural revolution, that is autonomous machines, AI, software, robotics. So that's what we're heading on. So in terms of the current state of agriculture, so traditionally, still even in UK, in Europe, Latin America as well, other countries, Asia Pacific and so on. Practices and knowledge are being handed down to generations. So how to cultivate the land, how to organize your farm, so on. Of course, manual labor is still a thing, especially when we talk about picking crops and harvesting, still a manual labor. Yes, we got harvester combiners, we got big machinery that's able to harvest huge quantities of crops and food as well. So those, sorry, too much audio. So those became more and more used now at the moment. Of course, this introduction helps to grow population. Population growth is directly linked to agriculture. So many challenges at the moment in terms of what's happening in Europe, on US. We have many challenges in terms of labor shortages. Climate change is a big factor. Increase in cost in materials, machinery, and so on. The costs have been increasing, and of course, everyone wants the food to be inexpensive, but all this cost is being assumed by the farmers. That is a big challenge that they have. Therefore, they need to try to find a balance between how much they can produce and what is the overall cost related to production and harvesting. Of course, one of the biggest things that drives to reduce some kind of cost to farmers is the introduction of machinery and reduction of human labor, actually. This is a trend, and this is stay here for the long term. In terms of the economics and environmental impacts of these challenges, of course, as we said, labor challenges, we're going to talk about a little bit in a moment. Social factors, for instance, the invasion in Ukraine last year, or actually 2 years now. Ukraine is one of the biggest land producers of wheat, I believe, and that's been impacted. So of course there's a big impact globally on that area, but that drives the costs up to our food supply, and of course the labor market is also impacted, because in this case many of the pickers of coming from Eastern Europe, mainly for Ukraine and in many farms, and this also been affected. So we got here in the UK farmers that are hiring now from Asia, from Thailand, from other countries, from Iran as well, from many countries as well. So they're trying to leverage that problem, but it's very difficult. And of course, the agriculture as such is highly susceptible to climate change. We've seen last year, even or this year, the summer hasn't started, so farmers are having problems with the crops, especially, for instance, and one thing that we're currently working on is, as a Fox Robotics company, we're working in a robotics device that helps farmers with strawberries, blueberries, and all type of berries. So they haven't even started to get the proper bloom on the plants, because the weather is not there. It generally started in April or earlier. Now we're pretty much June, almost July now, and the production is quite impacted. So everything because climate change. So this is a big impact on that. So in terms of challenges, we was talking about increased wages. Everyone wants to get paid more. Everything is more expensive to buy, and UK and EU is exactly the same. So farmers want to focus especially in terms of sustainability. So they want to ensure that the sustainable crops, the zero carbon footprint, because there are also government requirements that try to reduce the impact of fossil fuels, that drive sustainability as well, and that also they want to decrease the link and also the availability of farmers or pickers, sorry, or manual labor. So in this graph, what we've seen, we've done some analysis with with the industry. We found, for instance, that on most of the farmers that requires a lot of people working, they have a percentage more than 50% is what they used to pick, let's say picking fruit or picking anything on that. So the remaining percentage is divided basically in how long they take to transport. We've seen that often. Farmers on blueberries or strawberries, they have to work for polytunnels of 200 meters long by every field by 300-400 meters, and you repeat the field across many areas. So far, the pickers need to work all the time. So that's an issue. That's a big percentage of wasting time. Queuing as well, because they go to a central point where they need to wait for the fruit to be inspected, to be qualified, to gather data. We've seen farmers still collecting data with pen and paper. That who are you, what you do, your weight collected, where you've been collecting the fruit from, and they take the data. That is also a percentage time that is wasted. And also, of course, is walking back, right, and taking the trays and so on. So this is a big issue. So what happens if we somehow reduce that percentage and we increase the time of picking? So productivity of the farm goes up because farmers sell what they can produce. We've seen in the news many times that crops being left rotten on the fields because there is no one to pick. Or they have some people, they cannot pick all because they don't have enough people. So we need, and the idea behind robotics in agriculture is to reduce that big gap and to increase the production. So this is the issue. So loss in productivity is quite high, and we mentioned data being collected on hand. Yes, that's a good scenario. Then, for instance, when they collect who the picker is, how much they collected, the time, the day, the time of the day, the name of the picker or the ID of the picker, they go back an Excel spreadsheet and they try to extract that information because go to the payroll system or go to the statistical analysis in terms of what they have done or produced during that week. But the data is old already, right? So what happens if we can capture that rate in real time? So that is also an increase in productivity and data science for the farmer in the future. So now if we talk about a little bit in terms of the automation. So the automation, the idea behind that of everyone probably here understands is trying to facilitate the process, trying to make sure the process is repetitive, make sure the process can be result in quality, can be improved in terms of the task, can be facilitate the task and can be standardized, right? So what happens if we improve that and make sure it's automated? So robotics combines all this. So we're trying to bring all the terms of the automation into that, with computer science as well, and of course all the areas in terms of the robotics itself. So in terms of this, let's say the importance of technology within agriculture, this is vital for the industry. It's vital for the benefit of the country, vital for benefit of the society itself. The reason is simple. Everyone can understand why. Is if we got a good supply chain of food that could be reliable, we might be able to reduce costs to the end consumer, but at the same time increase profits to the farmer. So this is one of the biggest objectives that robotics is in agriculture trying to achieve, right? And of course, yes, it could be seen that we want to reduce the amount of people working on picking, but this is not necessarily true. So the reality is that people on the farms are very difficult to find. Pickers are really extremely difficult to find now. So because people are more educated now, they want to do other jobs, they want to stay on the big cities. So through automation, the people that is able to be hired for this type of works that will be doing something else, like, for instance, managing the robot fleet, right? Supervising other activities, and also increasing, the possibility to have better salaries as well. So this is what's happening actually on the industry. This is very similar to happening in the warehousing industry that is happening now. They got less people working, picking stuff within warehouses, and we got more robotics. So means that people are having something else to do. And this another use case that that is being disclosed and published on this Amazon. I think so they have done something about it in terms of the use case and define. So in terms of the robotics in farming, the intention, of course, is to streamline the process, right? To ensure that we, with the use of machinery, we can facilitate and reduce the fruit or the fruit or the crop that could be potentially be left too long in the plant. So strawberries, raspberries, blueberries, etc. If they stay too long, it got too ripen, so therefore they needs to be thrown away. So that's another, issue with the productivity. So we can pick the fruit on time, the right moment, we can reduce that. But of course, through the use of automation as well, we might be able to detect if any health issues of the plant in real time, enough to react and to advise and to tell the farmer that something is happening with the plant. So the farmer can be able to identify the problem and go through the process to spray chemicals or basically or kill the weeds and so on. So this is what we're looking into, is to try to get this technology to improve these issues. So in terms of robotics, type of technology that has actually been used in agriculture, drones for surveying, but is in open land, not in polytunnels, because the difficulty of navigating in polytunnels with drones. We talk about harvesting, harvesters, which is totally autonomous without people. Actually, big machines, harvesting machines, that most of them have a GPS systems on it. They can go straight online. They're using some of them using something called an RTK system. We talk about in a second about an RTKs. Robot arms used to pick fruits. Now we got robots that pick strawberries, robots that pick apples, robots that are able to pick tomatoes and pears and so on. So those are already here and actually been in testing. Not many of those are used on big farms. Most of those are just research and development and just starting going into the market. Precision robotics or precision agriculture is very important as well, especially when, for instance, you're trying to identify within a field where the weed is. So classify the weeds, identify the location of the weeds, and treat the weeds. That's something that is being done. There is a company that has quite recently went to administration in the UK. It was called Small Robot Company. Brilliant company. They have an arable land robot that was able to navigate and locate every single weed on the field, located in a GPS coordinate with precision location, less than 2.5 centimeters accuracy. And then of that information being sent to central server, another robot with a laser, we just zap it. So we just kill the weed. So what was the benefit of it? Is no chemicals, right? Is no chemicals in that. So I'm afraid that company went to administration because funding. So that's one of the biggest issues. But the technology is there, it's available. So if you want to buy that IP, it's available on that. For a couple of million, you will get that IP for you guys. So in terms of, for instance, other things that we look into robotics is transportation. Transportation actually is being done by someone driving a van or driving a wheelie bin or driving, I don't know, a buggy or even a tractor. Why we need to spend time with that person, rather that we can do it autonomously, right? Navigating, transporting seedlings, or doing any kind of other activities. That could be done autonomously with a machine, right? For that, we were going to go in a second about that, and I can spend more time on that. So this is pretty much a very high-level overview of what's happening in robotics in agriculture. There's many other things. We're going to talk about the use cases on that. So in terms of robotics, let's say machines, we got tractors, we got logistic machines, we have drones, harvesters, we talk about precision agriculture. There is other companies that, for instance, they're doing yield prediction. For yield prediction, they go through the field and identify in a vineyard, for instance, how big is your every single vine with all the grapes and so on. With just vision, is able to detect how big it is, calculate or estimate the number of grapes on the weight and the maturity level, right? And then report it back to the farmer. So the farmer say, yes, we can pick this area. We wait for next week for this one, or for 2 weeks in this one. So that helps into the logistics. So this is another area of robotics that many companies work in. So to work in terms of precision, we was talking about RTK, which is a flavor of GPS. I don't know if everyone knows what an RTK system is. It's real-time kinematics. Basically, what it is a correction between a GPS-based station, that's stationary, and you got a rover with another GPS. Both communicate to each other, but both at the same time see the satellites that you have on the constellations. So the more satellites you see on this, you can calculate what is the deviation or what is the margin of error on your rover. So the intention of this technology is that able to detect accuracy of 2.5 centimeters radius from where you are. So it's tiny. Normal GPS, where you are, you got about 2 to 3 meters. So that's not good enough for agriculture, because we need to go dead center, we need to go straight in line, we have to go to a specific point. RTK is one of the biggest solutions on that. So I mentioned IoT. IoT devices needs to be integrated in terms of automation and precision agriculture. Why? Because with IoT, we can monitor the status of the humidity of plants, the status of the quality of air, the status of the chemical composition on the floor and on the ground. So all this data can be gathered and analyzed and be sent to the farmer with one objective: to, for instance, send a robot to say, okay, we need more chemicals to fertilizers in this small patch, but this patch have enough, this patch is okay, but this one needs more. So robot can deliver precisely the exact quantity required for that, right? So on our use cases, we look into all the type of use cases. AI is everywhere now. That's the boom now of the keyword now. But the AI side, it could be divided in several categories. So one is data science, identify what could be the next areas to harvest, or what is the trend of productivity within a specific field. So this is something that is also being used in AI, and of course the prediction of growth within the plant as well. On our companies, for instance, we're going to talk about the company called Dogtooth in a second. They use AI, basically a classifier. Classifies a neural network we talk about in a second, that is able to classify images, and based on the statistics, determine if that image belongs to a specific determined characteristic that you have defined. So there's very high level description on that. And of course, sensors. This is a ton about sensors that are available to improve this topic. So light sensors, humidity sensors, air pressure sensors, hydrogen sensors, and any kind of sensors that be able to be integrated into IoT systems to work on that. So we look into IoT systems, so how they communicate. So yes, there is BT has done the highway, what's the name? BT Highway, I think. Sam, you remember that? Road highways. Sam worked for me when I started the company, so he talked about it in a second. So I'm surprised to see him here. Hi, Sam. So Road Highways is an initiative from BT that tried to establish 5G networks around the country and trying to bring farming into that. There is, of course, the issue that there is no 5G available in every farm. And the objective of that is because the high bandwidth of 5G will be able to send and even process all, the theory could be the processing all the information, even the navigation zone in a central point. So it could be done. But not all farms have access to 5G. So we're still seeing farms, they have even 4G. If you're lucky, you have 2G, right? So that's true. And also, even if you have, for instance, we've seen in farms when we do our tests in my company, we've seen farms, they have no so bad reception even from GPS. So like a black hole. There's no 4G, there's no GPS, there's nothing. So you need to look into how we're going to solve the problem. And my company is working on that area. So benefits. We look into benefits now. Of course, the benefits that we mentioned before is increased productivity. The more productivity the farms can do, the more they can sell, the more profit they can have, and of course, the more people could potentially hire as well. Productivity is important. There is of course the reduction of labor costs. If we optimize the number of people working on farms, not necessarily having hundreds, we working with a farm that's about on peak season is about 1,200 pickers, right? And seasonal workers. So seasonal workers work from March, April to October, November, depending of the crop. So it's pretty much the entire year, right? And despite what been the normal understanding is that pickers is not a skilled job. It is a skilled job, heavily skilled job, because we've seen pickers that are able, for instance, to work with two hands pretty much without looking, right? And in a let's say in 5 minutes, might be able to pick 2-3 kilograms of fruit per minute with two hands, just like this. It's very, very impressive. But without seeing they pick the right one, the correct fruit, the correct size, they do it over and over again, right? So that's a skill. And we need to be, conscious about that as well. So, but replacing or optimizing this labor with robotics will be able to continue working with this because people get tired, get exhausted. So you got a shift or two shifts. What happens if you have robotics and people working at the same time? You reduce the shift of the people, but you can have 24/7 working with the robots, right? So that's a possibility. For instance, in robotics, you can pick, let's say, strawberries during the night. That action makes the strawberry more flavor, instead of the day, right? There's been a study on that. If you pick it during the night, the strawberries taste better than if you pick in the day. That very strange, but it is true. So that's why the automation is quite important. Robotics is quite important in terms of the farming side. So we was discussing very briefly about the precision and accuracy, especially navigation. So that should be fine. To make sure things are sustainable and environmental benefits, we was saying, for instance, the reduction of carbon footprint. So instead of having tractors with diesel, we have a big robot that be able to transport 5 tons, 2 tons, 1 ton of produce across the farm, transporting material, transporting tools, transporting seedlings, doing any activities. That will reduce a person driving a van or driving a vehicle that is generally powered by fossil fuels. So that's interesting. Now, data is something that is king. Data is where we need to concentrate. The more data you have from the farmers, the more data points you might be able to identify and generate inputs to the farmers so they can have better decisions. Better decisions in terms when to start to plant, when to harvest, how much to harvest. Because, I don't know, supermarkets or producer organizations might be able to ask, I want 2 tons of or 20 tons of strawberries. By when? By tomorrow. Fine, great. You got your target. But if you got more data, you'll be able to identify where exactly on the field you can get that 20 tons from, right? And then you can plan around it. So you can plan with people or you can plan with robots, right? So harvest in this area, in this area, in this area, you go to 20 tons, right? And speed is important as well. So the faster you pick the fruit and send it to the chillers, the easy and less risk of the fruit get damaged very quickly, right? Well, we don't have a good summer in this country, but in other countries, Spain or France, they have a very better, or Italy, much better weather than here. They need to transport the fruit or the harvest that is susceptible to heat very quickly to a chiller, right? Otherwise, you lose a lot of quality of the fruit. So that's why, for instance, data-driven decision is important. In terms of the market, of course, you can use those data points captured by the system, by the robotics, by the AI, just to improve your overall process within the farm. We've seen that very often as well. So, in terms of case studies, I'm going to introduce my company, Fox Robotics, that's me. This is a robot, Hugo. Hugo is an autonomous machine. This is our generation 2. We got generation 3 in a second. I will show you in a second. So I founded the company in 2017. The intention of the company was to work only in warehousing when I started 2017. So we started to build a robot, very small robot, floor level, just for warehousing. So during that process of development, I met with many farmers, and they have warehousing, and they have polytunnels, they have open fields. They asked me the same question: can you do this in warehousing but outdoors? So that was the pivotal time. Some remembers that. So we started to work in terms of what we can do to develop this machine, right? So our first generation of Hugo, many problems. We got problems with suspension, we got problems with navigation, we got problems with everything. So that's gone. So second generation is this machine here. We solved many issues in terms of many mechanical issues. We had some issues in other areas that we resolved it. Now our generation 3, show you in a second, solved most of the problems, and we are now in commercial trials. Of course, we look into our solution. So basically, our initial use case is logistics. We got many use cases. So our first, let's say, part of the solution is the pickers on a field, on a polytunnel, let's say 400 meters inside the tunnel, right? And the picker is picking, right? So they have a small device that we call HolaHop. Press a button that sends, guess what? A GPS RTK location to a robot, to a cloud and to a robot. Robot says, oh, I got someone else who needs me, right? So that information is collected and then sent to the robot. The robot will autonomously navigate based on a specific predetermined map that we have to build, and identify where is the best route. If the route is blocked by an obstacle, by a car, by a van, by an animal, whatever, is going to reroute, and they calculate the new route. So robot goes to the picker put the produce there, capture the information of the picker with an RFID, who you are, how much weight you put on the robot. That's data. Remember that we was talking about farmers, capturing data by paper? We got it now autonomously on the machine. So we capture that information and we send it to the farmer real time, right? So it's a benefit for them. Real time, they see which one is my best picker, which one is my worst picker. What can I do to improve that picker, right? Is that row that pickers are collecting is producing enough? So I also be able to capture that information. When this is done, the person just press a button on the robot and off you go. The robot goes to where? To the next picker, and to the next picker. Until the robot is completely full. When it's detected full, goes back to a destination. Could be a chiller, could be a truck, could be another robot transporting bigger load. And that will be able to go to the main location as a big hub. And the process repeats itself. So by doing this, we reduce that percentage that we were discussing a moment ago of queuing, walking, transporting, and other activities and capturing data to higher output and in terms of the productivity for the farm. So this is one of our use cases that my company, Fox Robotics, is working on. So we got some use cases. So our robot HugoRT is being designed already to do many other activities. It's a platform, right? It's like a Lego. You put whatever things on top of the robot. You got many connectivities. You got many I/O ports and so on that we can do lots of stuff. So we can do towing. That's a mechanical, connection, mechanical link. But we have a capacity. This small robot has a capacity of about 600 kilograms towing. Quite a lot. But you can also mow. So we can add, and we're working on things like adding a mower in the robot and just mow. Because, for instance, farmers in polytunnels, they need to mow every week or less the polytunnels because they grow too much. Because they're polytunnel, they grow a lot. The micro weather they've been creating polytunnels, increases the growth of the weeds and the grass and so on. So they need to mow. That's an activity. Generally, they do it by a person with a van or with a truck or a buggy, and that just the fact of moving this motor device like a buggy or so on with a mower, you polluting the fruit because the exhaust is affecting the fruit. Somehow it stick to it. So if we have something that's electrical, there's less pollution. So therefore, the fruit has more quality, right? So this is one of our things. So yield prediction, again, you use the same machine to send the robot to a specific route across the farm. And with cameras and AI, we'll be able to predict and determine every single fruit or every single grow or crop, the maturity level, the size. By size, we can calculate the approximate weight of per device, per fruit or per strawberry or blueberry and so on. So that gets that data, the input data with the location of the GPS location. The farmer will be able to identify in the polytunnels in which area you have the most probability to go and harvest fruit on big quantities to gather the fruit that you've been requested to produce and to sell. So spraying, that's another possibility, spraying or UV light, where you have a possibility to have a sprayer. There is now sprayers that are able to actually push or send a specific size of droplets into the fruit, but not the entire field, just sections. So you reduce the need of having to use too much chemicals and so on, pesticides and so all this. So plowing as well, you have a small plower you can add into the robot, and you have a small, you can have n number of robots doing plowing at the same time. You might be able to reduce the need of a bigger machine, a bigger plow, right? So this is a possibility we have. And also, of course, security watch, because farmers, they have high incidence of theft because there is big fields. People have the tendency to go there, see what machinery they can steal. But you can use a robot like ours with a camera, night vision, and send the robot running around with alarm, connected to the police, connected to the farmer, and we see something that is not there through, of course, through the AI. You can capture what's the person doing something, take a picture, take a video, send message to the police or to the person having responsible for the security of the place. So this is some of the use cases. That we got many more use cases for our machine. So now in terms of safety standards, before we go to the next use case, there's many safety standards. Safety is something very important in robotics, right? If we want to have a device that is compliant with the law, compliant with safety regulations, this is just a small extract of safety standards. Safety, this number really probably doesn't mean much to you guys, but there are safety systems for safety certification on standards for electrical that have to be specific to ensure that you don't kill someone because you got a voltage in the wrong place. Or safety machinery, in terms of how just to stop the machine safely. It's not just put up safety stop red button, the safety stop. It's not. They have a design, right? They got a category. You got PLD category 3 or PLD category 4, depending on your machine, depending on the voltage, depending on how big your machine is, how fast it goes, right? What's the distance of stopping distance? If you go 3, 4, 6, 10 miles an hour, what's the minimum or the maximum distance that you can stop before killing someone or breaking a bone or smashing someone or just pushing someone to the floor? So all these considerations are in these specific standards. So we got requirements for robotics as well. There is the ISO 10218 that is for robotics. That is a specific standard defined how a robot should be able to be designed to be safe to work with people, right? You have in industry robotics on industry like automotive industry. You got these robot arms that spot welders and other type of robots that are actually isolated from people, right? And even Amazon have isolated from people. But in this case, in these scenarios, we can't. We need to work with people, right? Because you have to interact with people. So these kind of safety standards are key in terms of what you need to do. And of course, there is the European directive for machinery directive. That is, let's say, the base of many of the standards. So this is just a small extract of standards that we need to use. So our second use case is Dogtooth. Dogtooth is a company located in Cambridge. What they do, they specialize in an arm, right? That arm is able to to select the strawberries and do the inverse kinematics to try to reach the strawberry on a traditional three-dimensional space, grab it, put it on a chamber where it's a camera, and the camera have mirrors, and we're able to detect if the strawberry is the right size, is the right shape, if the right weight, and if so, is then sent, put it in a tray with punnets, right? If not, it's discarded, right? That is their core IP, but they don't do navigation. This machine is not autonomous; it doesn't navigate. How they use is just have a wire, an operator. They need to, position the robot in a right place, connect it to the wire, and let the robot run on the wire. It doesn't go autonomous, right? So this is one of the things that this robot doesn't have. So this is pretty much one of the other secondary, let's say, use case. Almost finished. So yes, as a conclusions for this first part, before we go to Q&A, is in terms of key points is robotics is here to stay for agriculture. This is, let's say, the next generation or the next revolution in agriculture. Will facilitate, will increase productivity, will increase quality, will reduce costs for farmers, will increase profit for the farmers as well, create new jobs, totally different. There is more and more robotic companies than before. AI also will be included as well. And of course, we're looking, of course, our companies looking to working with more partnerships for university. With the University of Surrey, we are working on a grant. Surrey University and Fox Robotics working on a grant in terms of the navigation. We have our own navigation stack, but Surrey University is adding part of the IP into our navigation stack. Yeah, questions? I can do now technical if you want.
Just a question about your vehicle that you've designed, the latest one. It's just a technical question. What sort of, presumably it has got sensors on it to identify obstructions that it might come across on a farm, of which there are many. And what are your sensors based on?
That's a good question. So I tested many sensors during the first steps of the R&D for the robot. We came across the best way at the moment is using, you have one consideration is cost. The moment cost is a critical factor. You have a robot that is too expensive, not going to buy it. No one is going to buy it. So you need to find out what's the best sensor available that allows you to do, identification obstacles, navigation, and so on. In our case, we use stereoscopic cameras with depth sensor, right? So cameras. In our case, we use only cameras, right? So there is, of course, the possibility to use 3D lidars. 3D lidars are decreasing in cost, but still quite expensive, depending on number of, let's say, lines that you have. The more lines you have on the horizontal view, it's get more expensive. We got, Velodyne, 32 lines. It could be cost £5,000. It would be more £5,000 more to the farmer to pay. If we use only cameras and we use RTAP, for instance, or visual visual slam or so on, we might be able to detect those obstacles, using just vision. Right?
So whose vision are you using? Are you just using image recognition technology?
Yeah, we use vision recognition. Is that so? We got on a stack on AI that is able to identify objects, is able to do path segmentation, obstacle segmentation. We do segmentation of many, let's say, labels, and those are being added and sent to our navigation, our base move stack, and we'll be able to determine where to go. So you got like a cycle. You got cameras that fit into the main controller, let's say the main computer, but you got other sensors like optical encoders for odometry, right?
So what else? Is there a problem at night? Because obviously farmers work.
No, at night because our robot. Not sure if you can. I think so. I got a picture of the robot somewhere. Oh yeah, this one. So. Our robot has lights on the sides, right? You got floodlights that are able to send enough light to the cameras that you can navigate, right? But of course, you also have navigation. You got the RTK that allows you to position yourself. You got IMUs, right? That are able to identify, your heading, your orientation, and XY coordinates. So determines your orientation of the robot. So we got more stuff. Yeah.
I assume that within any one farm, all this robotic machinery communicating together and the clouds bring the data back all sits within one big security perimeter. So what do you do if you're going to get denial of service attack coming in? What do you do to keep yourself secure?
Good question. Yes, so one of my skills is I'm a certified ethical hacker, right? So in our case, for instance, we put let's say, controls in place to minimize the attack vectors from a threat actor, right? So at the moment, most of the robotic systems are not integrated with another manufacturers. So you got robot from company A doesn't talk with robotics from company B. So at the moment, the industry is like everyone is in its own silo. In our case, we have defined and put in place controls that will reduce your attack vector. So denial of service attack is something very difficult to prevent because it's just flood of TCP, UDP against ports that you got open, right? Just trying to steal your services. That's quite hard, but there is some control that you might be able to implement. Vulnerability scanners or port scanners, that can be done. You can add firewalls onto that just to reduce the number of ports open to the wild. You can, for instance, having in terms of firewall configurations, IP to IP source destination, port destination already defined, so you reduce who's going to connect to, right? But also there's many standards, ISO 27001 in terms of controls for cybersecurity. You have other type of let's say, infrastructure infrastructure designs, like let's say the Purdue model. The Purdue model is oriented in terms of OT systems, of this operation technology. The way you define, you layer your components, right? So you might be able to layer your internal robot infrastructure into layers and protect them. Where you need to protect what? Your core is your main computer, your safety system, your sensors. All those could be living in different layers and communicate with the specific rules in between them. So that also reduces your threat vectors, your threat attacks vectors. So if you route communicates to the cloud, then you need to have on the cloud side WAF, which is web application firewalls. You can have IDS or IPS, which is intrusion prevention systems or intrusion detection systems, to minimize, external attackers against the cloud systems to might be able to get link into your robot. So the more ways you protect in different areas, you reduce your space of vector attacks, right? Patching is another thing, right? You need to ensure that your patching is all the time there for your systems or your operational system and applications. The way you architecture the system, the way you define and create and harden the operational system is very important. There's so many things that in terms of cybersecurity you can implement to secure your robot. Most of the companies, they don't do it, right? But this is the recommendation.
Can I just ask one supplementary question? Because it seems to me that most farmers are not going to become PhD IT experts. So there's two elements to this, isn't there? There's the element of automating and introducing robotics in farming for all the excellent reasons you've identified. And there's another business opportunity to say, we'll provide the service to keep you secure. So if you buy our solution, you get all the machinery and the bits and all the connectivity and the software and stuff, and you also get us to look after you. Is that something that you do?
Yes. But I mean, from my perspective, it is the responsibility of the company who is creating the robotics technology to ensure that if you buy something, it's something that you don't need to invest later on how to protect it. That should be defined and designed from the beginning, from conceptualization, in terms to be secure, right? So I've seen other companies that just have pretty much a main computer, a modem to the internet, that's it. So with Wi-Fi, so easy to hack and be able to accept any external communication. Then in these cases, you might need to pay more. But why you need to pay something, but even if you have as a responsible company to create something that is safe from the beginning, right? So that's the key. One of the biggest issues with not securing your systems is that me as a security practitioner as well, if you have your computer or your robot being hacked, that machine could be used to attack another company, let's say a bank. Who's going to be liable for that attack to the bank? The one who do the robot, the one who is using the robot, or the bank, right? That goes to who made the robot, right? You have to get your controls in place. You have to reduce, you can never be 100% hack-proof. That's not true, right? But you have to make sure it's very difficult to be hacked, to reduce your liability, and to decrease the possibility of your device to be used as a jumping point to another attack. Yeah.
Julian asks, what's the state of play using UAV-borne hyperspectral remote sensing to measure fruit biochemical concentrations, for example, acidity, sugar, tannins, and so on?
Wow. Wow, that's a quite heavy
I
question.
thought I'd start you off with an easy one.
Yeah, and actually, I don't know. Honest with you, I'm not working in that area. It's not my expertise. We are, as a company, we're not working on that area. Whatever I say, it could be absolutely wrong. I will not be able to answer that question. But I'm not sure how, with the camera, you can, unless you have a visual spectrometer, which is very expensive, could be bulky, to analyze the composition of chemicals and composition of that. So with drones, I don't know, honestly. That's a good question, but I'm really sorry. I have no way to answer your question.
Well, I think an honest answer is much appreciated. So let's try a slightly easier one then. Do you have any plans about adding a picking function to your robots as well?
We do. This is an opportunity that is a possibility. To have an robot arm. Actually, on the top of the robot, we can, let's see if it's somewhere. Yeah, you can see it. You can take out all the trays, the green ones, and put in the middle a robot arm in the middle. We can do it. It's just to add the controller, having an Ethernet connection to the main controller, and having the external power supply. You're in. Yeah, use CAN bus or something like that, and it's no big deal.
Okay. Oh, thank you so much for the presentation. My question basically is in terms of the cost. I know that every time we are introducing technologies into the agricultural sector, we are always talking about funds, like how expensive it is to develop such a solution. So I just wanted to find out how is the absorption of the robots to the farmers, and how do you cater for the different levels of farmers who are there, because there are different levels of farmers. Are they different versions of the projects that cater for the different economic status level of each farmer?
Yes, that's a good question. So we need to talk about ROI, the return of investment. So when we present this to the farmers, we identify that ROI was between approximately one season. One season was enough to pay for the robot, right? So now how you identify, how you reduce your cost is iteration. At the moment, honestly, when I started, I spent so much money just identify every single possible part I can use, right? If this is the correct, computer, so buy this one, test it, install all the OS, test if they have enough power, GPU capacity, have enough CPUs, have enough memory, and see if that is big enough or small enough to fit into the constraint of the machine itself. So everything is just try, fail, and try and fail. So during the R&D process, it's very expensive. But once you standardize your robot, when you standardize your parts, when you standardize and you design to build and you design to manufacture and to assemble, things will become even cheaper with time. The more robots you sell, the cheaper it becomes because you can have more discounts and so on. So that's one way to do it. Now, farmers, yes, we've been working with the small farmers and with big farmers. With the small farmers, they were happy to say, I can have 2 robots and it can be paid in 1 season, right? Or 2 seasons. Because after that, it's just a recurrent cost of licenses. But they don't need to pay, they can use the road 24/7, and to cover, let's say 24/7 with people, you need 3-4 shifts with people. It becomes more expensive, right, the long run. But yes, that's pretty much the idea. Is just, but this is well accepted at the moment.
Thank you. A much more simpler question, perhaps. You showed the robot picking, I think it was a tomato, with like 2 fingers on it. Now, if you're picking a strawberry or something soft, do you actually have fingers that hold that fruit, and then you pull it off, or do you cut it off, or how do you actually extract the fruit, or does it drop into something and then you put it into a...
Yes, good question. So this is, for instance, of course, not my company, but this Dogtooth, the other use case I mentioned here. Dogtooth, again, is a company based in Cambridge. Nothing to do with us, but it's a very good use case. So they have, the rod arm has like a small tiny scissors that is able to go in the stem, just cut it. And it doesn't drop, it's just hanging. And they put in the chamber to check the fruit. The fruit is good, they move the arm into the punnet that needs to be filled and drop it there. So one of the benefits is that no one is touching the fruit. With people, they touch the fruit, right? So yes, you have that less quality with someone, touching the fruit. With this robot, you don't need to. You just pinch the stem, cut the stem, move, and drop it. So this robot is fantastic in terms of how they do it, and they have done quite a lot of work on that area.
I wanted to ask a question regarding, since like we established that farmers are not IT professionals, and so have you faced any operational failures in your previous use cases, and how did you tackle it with respect to design perspectives? For example, with respect to precision or accuracy, if there were any operational failures with respect to robot that you encountered on field, and if there was any, how did you plan to change that in the next robot design that you will plan to build or whatever?
So when we designed the Hugo RT, we went through a lot of, let's say, ideas iterations with the farmers, right? We were working with them very closely because one of the biggest constraints is the dimension constraint, right? On polytunnels, we got polytunnels that got about 70 centimeters width. It's just enough for 1 people to go, right? But these constraints are so important. But then, of course, how you adapt this into a robot that can go a bigger place with bigger capacity. In our case, it's just changing the top. That's it. You just change the white top. Let me show you. Yeah, where you got the trace. If you go bigger, you have bigger constraint or bigger space, change it for a bigger platform, and you got the problem solved. So this is the idea of this robot. It's become more flexible, become as a let's say a platform. It's a Lego. You add stuff and you grow as you want, as you need. So that way we try to cater those needs that we already identify in the market.
During the winter period, when temperatures are lower, perhaps there's not a lot of agriculture actually going on. So, what do the robots do? Do they just sit in the barn and wait for the season to change, or are you mostly targeting places where it's
that's a good question.
Where it's a 24-hour operation,
yeah.
Sort of glass house type
yes.
cultivation?
We working with farms in all the spectrums, from glass houses that they pretty much are working from February to November, to open fields, tunnels for open fields, that is from March, April to September, October, right? Or polytunnels that also is about the same time. And what we've seen that in winter time, farmers still working because they need to prune, they need to transport, they need to take out all the plants that died. And all this activity, which is manual, can be assisted by the robot, right? Yes, the robot will be able to remove the plant that which is dead, but one person with the robot will just go and put it as a trash bin with wheels, right? Intelligent trash bin, let's put it this way. So in that way, the idea is to maximize the usage of the robot. And this is one of the objectives, is the more you use the robot or this kind of technology, you'll be able to have a better ROI.
More of a general question, really. Given the robotics industry is sort of embryonic and maybe cottage industry at the moment, and it seems to benefit large farms mostly at the expense of small farms.
Yeah.
Is there any government interest in supporting the robotics industry and sort of supporting small farmers in getting robotics in, or is it just left to everybody to fight for their own corner?
I have some knowledge about it. I'm not an expert on that area because I'm not working on that specific topic between farmers and the government. My understanding is that how the farming industry works in this country is farmers, let's say, are part of something called producer organizations. The producer organizations are backed up by the government, but these producer organizations are the ones to sell to supermarkets. So small and medium farms, they go to this collective called producer organization, and this producer organization says, okay, we have this quota. That's what I understand. I might be wrong that bit. So we got 200 tons of blueberries. So all these small farms say, okay, I can produce 50, I can produce 100, I can produce 10 or 20, right? And they send that to these producer organizations, they commercialize it, and they sell it. No, the government, what I understand, is that they have some grants to them, to the producer organization. And the producer organizations send the grant, those benefits to the farmers. So in fact, they will be able to reduce the final, let's say, the final cost of the robot by a percentage. I'm not sure how much is. This is what I understand. So they will be able to have a better capacity to acquire technology through the government and through the producer organizations. The producer organizations pretty much for everything, from berries to arable land, potatoes, tomatoes, and so on. So there's producer organizations. You can find in the Gov UK the producer organizations structure, and they show you. This is the same, very similar way how the EU works. They have, every country has their own producer organization, and they do very similarly. Yep. That's the idea, is benefiting the farmer, the small, the medium, and we have bigger farmers that sell directly to supermarkets. That's the big farmers, right? And they can pay for them. Yes.
So a question here about safety. You talked on your slide, I think, about not introducing more risk by bringing the robots in. I guess generally farming seemed to be a very risky industry compared with others. The safety levels are much lower.
Yes.
There's more injuries, there's more fatalities. Does the introduction of robotics help with bringing down the risk factors in farming? Is that also a benefit?
It is definitely a benefit. You're right in terms of the risk of the farmers. The farmers at this stage, they are more prone to risk, but the farmers that we're working with, they are very conscious about safety, and they try to introduce health and safety concepts and recommendations and processes into the facilities, into their production. So that also drives down this kind of safety issues. So by introducing autonomous technology, you have a risk, and you need to mitigate the risk. But the risk is not only for the company who produces the robots. The risk is also to the farmer itself. It's a combination. If you have a device that is being defined, created, and designed to be compliant with the specific safety recommendations, but if your farm doesn't have any safety, you still have a high level risk. So it's a balance between what, as a farmer, you do to improve education, training, using the right PPE equipment, teaching how to use the robot, plus the robot having the controls to reduce your safety or your risk for safety, you minimize your overall risk.
Henry, thank you very much indeed for a very wide-ranging talk. I think you've covered the history of agriculture as well as the introduction of robotics. And I'm very grateful for exploring the whole field, and we're very, very much aware of just how fast it's growing. And we wish you and your company well in the future, and we'd like to hear how it goes.
Thank you.
And how you go on there.
Thank you so much. Thank you. Thank you.